Good morning. Good morning. Good morning.
For now. Need to grab one more pack.
Good morning. Welcome back. Have to come back after a week off. Luckily, we're starting off with a bang after Tuesday. I imagine you saw your test grades, so I do have your tests. There's still a little bit of motion on some of them, so continue to check the hub. But if you want to see your physical test, I will give it back to you next time. But if you want to see it today or tomorrow, just come by the office and I'll show it to you temporarily. But for now, we're not giving them back until everyone is taken and everything's graded. Everything has settled. Okay, so you ready? Need some unit 4. Is that right? Is this unit 4? Are we already there? It's almost December. Okay, so we have, wow, 2 sections, just more functions. I've already put this in your calendar, but we have one quiz. One quiz
Switch to the quizzes on everything, but that's the one.
No, it's just days 1 and 2. There are 2 sections.
Okay.
Yeah, so. Yeah, we're talking about the unit days, so. Day 3 will have a first section. On the 3 sections. There are 2 important sections, very, very important sections, so we're gonna spend a good amount of time on each one. But yeah, this is your near future, December 13th, the test. After that. Morning, made it. Yes.
Yeah.
I'm not gonna see you for a little while after that, so this is last hurrah for this year. Okay.
Yes. Oh, did I mess up? Okay, so it's whatever, maybe the 12th. Yeah, probably the 12th. Because there's one class, we'll have one class after that, so we have class on the 14th, is that right? Yeah, thank you. Okay, so no matter what you see on your calendar, I'm gonna change this here also, so I have it. So Tuesday the 12th. That's really helpful, thank you. So last year we were talking about functions. The relationship.
Which each input there is exactly 1 out, but I hope we're comfortable with that, comfortable with function notation. Today we start filling your library with a library of functions. So there are some functions that are just essential for you to know, like that, bam, without thought, without hesitation, you just got to know everything about it. The first one is constant function. F of x equals b, where b is a real number. I'm gonna go ahead and just cross this out here and do this instead. Because b, if it's just any constant, I just want to be able to put it right there. And you know what this is gonna look like? This is a horizontal line. So I don't want to nail it down to any particular points. That's why I'm crossing out the grid over there. Notice all of the coordinates on that line, 1 comma b, 2 comma b, is just f of x equals b. So domain for this from negative infinity to positive infinity, of course. Intercepts, there's just 1. Y-intercept is at 0 comma b. Is it odd or even? Is it? Does Baron speak the truth? Is it even? Baron, how did you know that? Thank you. This is even. While we're at it, it's been a while. Can you please check with your neighbor to see the definition of odd and even functions? A definition of an even function. Definition. So Baron has stated that even functions are symmetric or with respect to the y-axis. Perfect. That is one property of even functions. The definition of even functions. And remember, it starts like this. I'll put this up here. Even f of negative x equals f of x. Can you visualize that? Right, from the origin, you're going negative x, positive x, and then they just go, they're equal, the same thing. That's why it has symmetry over the y-axis. For odd, f of negative x equals negative f of x. And of course, the property is that's symmetric about the origin. So hopefully you could picture that as well. You take your negative x and your positive x, and then what happens? right? Negative x from the origin, negative x, positive x. And the output is opposite. That's so symmetric about the origin, or with respect to the origin. Okay, so 2 oh, constant functions, are they increasing or decreasing? They're constant. Neither. Yeah, end behavior. We haven't spoken about end behavior, have we? We have not. So what this is saying is, as x goes to infinity, f of x goes to, right, as x gets larger and larger and larger, where are the y values going? They're staying at b. So the end behavior here is, it's going to be, which is a little bit strange, but it's a, and what it just is there. Also, there's another end. X also goes to negative infinity. F of x goes to b as well. If you're not sure about what this means, hold on a minute while we do others that are a little bit more interesting. Okay, next one, identity function f of x equals x. I write this as y equals x because it's the exact same thing. Do you know what this function looks like? You better know what this looks like. I hope you do. Let's plot some points though. 2, 2, 3, 3, 4, 4. Yeah. So many points. When you have a grid, I do expect you to fill in as many points that fit in on the grid as possible.
Like I'm just driven up the dog.
Yeah. There we go. Okay. If you have a straight edge, you can use it if you want, but this is just your notes, so you have to just do your best. I messed up a little bit. I'm okay with that. I have the idea. Domain. Should we just say x is an element of all real numbers? Is that okay? Or you could do interval notation if you like. Intercepts. X-intercept. I guess we'll say x and y intercept are 0, 0. How about that? And y-intercept. Just trying to be efficient. It's not lazy. Efficient. Check Riley with your neighbor. Is it odd or even? If either. On the count of 3, what is it? 1, 2, 3. That's strange. Nice. Okay. Is it increasing or decreasing? Increasing for sure. End behavior. So it always looks like this. As x goes to infinity, y goes to, oh, not y. F of x goes to, excuse me. You see what's happening to the f of x values or the y values? They're also going to infinity. So namely, as x is getting bigger, like as these values get bigger, those y values are going to infinity. That's just how we yeah, thank you for n to on both the left and the right. As x goes to negative infinity, f of x. Yeah, good question. Let's see when we get there. Dun, dun, dun. I like that. It's kind of like a foreshadowing. Absolute value. Do you already know what this looks like? Y equals absolute value of x? Well, let's see. You plug in a 0, out comes a 0. You plug in a 1, out comes a 1. You plug in a, oops, you plug in any positive number, out comes the same positive number. Yeah? But if you plug in a negative number, out comes a positive number. So I saw some of you tracing this. Is this exactly what you were thinking? We describe this as a V. Interesting. Okay, domain. Oh, real numbers. Intercepts. Both. Is it odd or is it even? Even. Is it increasing or decreasing? Both. So let's do in intervals. Let's start from left to right. So we'll start with decreasing from negative infinity to 0, increasing 0 to infinity. Oh my gosh. And behavior as x goes to infinity. F of x goes to infinity. As x goes to negative infinity. And finish this with your neighbor, just make sure they did the right thing. Negative infinity. So as x goes to negative infinity, f of x goes to going up, right? Going to positive infinity as well. A reciprocal function. This one's an interesting one. What happens when you plug in a 0? A puppy dies. Don't do it. You can't divide by 0, right? Who would do that? We're not that cruel. So what we will plug in a 1 though. 1 over 1 is 1. Let's plug in another number like 2. 1/2. Okay, I think I'm gonna need to zoom. For you to zoom, you just have to bring your eye closer to the paper. Plug in a 3. 1/3. Did I get that 1/3 about right? Plug in a 4. How comes a 1/4? Something like that, maybe. Do you see what's happening? What shape is this making? It's definitely not a line, right? It's some sort of curve. Where's this curve going? Yeah, well, it's gonna do this kind of thing, isn't it? Is it ever gonna touch the x-axis? What's that called if it approaches but doesn't touch? You know, do you know what it's called? It's called an asymptote. Does that sound familiar? Asymptote. It approaches but does not touch. That's a good question. So y equals 0 is an asymptote. There's a P in there, but you don't pronounce it. Unless you incorrectly pronounce it as asymptote. It's completely wrong. Asymptote. Okay, let's plug in some more points. Like what else could I plug in? -1. If I plug in a -1, out comes a -1. If I plug in a -2, does it make sense that I'm putting the point where I am? Plug in a -3. These are sounding so familiar. Et cetera, et cetera. You see what it's gonna look like, don't you? Something like this. Again, approaching the x-axis or the line y equals 0. So do we have enough information to give us a domain? Would you please discuss with your neighbor, what's the domain of this function? Do we agree? So far, my impartial or my partial domain, we're good with that so far? Will you please show me what belongs in the missing areas? You have two hands up. Please show me what's missing. Uh, I understand why you're saying what you're saying, but really it's just 0. Which means we're not done with our graph, are we? But with the only thing we can't plug in is 0. Don't you agree? We just didn't plug in other stuff. But please discuss with your neighbor what happens when you plug in a number like 1/2. What do you get? So show me, what do you get? 2, right? So 1/2 comma 2. So there's more in this domain. How about when you plug in 1/3? What are you going to get? 3. Do you see what's going to happen here? How about 1/8? How high up is this thing going to go? Is it going to go infinitely high? It could go up to like 1,000,000. What's the x value if it goes up to 1,000,000? 1/1,000,000. Right, that's super close to the x-axis. Yeah, so it does go up. We just had a partial version of the graph here. Looks like this. So what we have is another asymptote. The other one was a horizontal asymptote. Of course, this one is a vertical asymptote. So now you see what the rest is going to look like. Like a -1/2, you get -2, etc. It's just going to go like this. When you graph this, I only care about 2 points. I just care about this point and this point. And I also care about 2 other things. The asymptotes. By the way, these curves here are called branches. When there are asymptotes involved, these are branches. So that this has 2 branches. This is a branch. Okay, so now let's finish up our intercepts. What are the intercepts? None. Is it odd or even? Isn't that strange? Increasing, decreasing. Discuss, what is it? I'm gonna call someone for this one. Okay. Ms. Lawrence, what do you think? Increasing, decreasing, both? What? Where? Who? How? Okay. Well, let's start from left to right. Remember, we're going to do the last word. So let's talk about this branch. What's that? I know it's increasing.
Yeah.
Oh, it's a decreasing? I know it's decreasing. Is it going down? Right? It's decreasing from -infinity to 0, or whether it's decreasing. How about actually? Yeah, the other way. That's what? Do we agree it's also decreasing then? Yeah. So basically it's decreasing everywhere but at 0. But let's just keep it decreasing from -infinity to 0 and 0 to infinity, and it's not increasing at all. Domain, by the way, if you want to say x doesn't equal 0, does it make sense that basically the same thing? So if it says interval notation, I like this. It doesn't specify except to be exclusions for the domain. Okay, and behavior as x goes to infinity, f of x. I'll let you finish this. I'll let you finish both of these. And I'll, of course, discuss with the neighbor. Okay. Here we go. I'm gonna call on, oh, everybody. As x goes to infinity, f of x is going to, please show me where it's going. X is going to. Show me, if you use your hands, you may. One of the two people answer, three people answer. If it's going to infinity, that means it's going up high, I think. Function is going up high, I think. It's going to a number called zero, right? When you plug in 100, you plug 100 in here, you have 100, pretty small. You plug in a million, 1 million, super small. You plug in a billion, are we ever actually gonna get to zero? No, but as x goes to infinity, f of x, I hope that makes sense, f of x is going to zero. Does it hit zero? It's just going to zero. That's kind of the limit. Can it make it to like -1? No, I can't get, you can see it, it's gonna approach it, but never like forever alone. And of course, as x goes to negative infinity, you show me what the answer is there. F of x goes to, hey, you get it, 0. You may think to yourself, oh wait, isn't that an end? And we'll talk about that in feedback. When we're talking about end behavior, we're talking about x going to infinity, x going to infinity. That's it. Oh my goodness. Have you seen this function before? F of x equals x squared. Yeah, so let's plug in some points. 0, 0, 1, 1, 2, 4, 3, 9, 4. We're not gonna do 16, am I? I'm gonna plug in negative numbers. I'm kind of doing a T-chart in my head, aren't I? I am doing T-charts in my head. I hate T-charts. I'm just going to build these. I'll show you how to get out of that T-chart frame of mind. The shape of course is called a parabola. Or as my calculus teacher said in university, parabola. Had a hard time with his R's and L's. Parabola. It was funny. Great mathematician.
Could you have to say like draw the reciprocal function, you would have to do that? Or
Yes,
is it just-
yes. Thank you, yeah. Thank you for reminding us. This is your library. You need to have these like that. You gotta know. For this one, I do want all the points that I have here, so I'm gonna want to see.
Did you give it to us by the name or the?
You'd see the function. You'd see the function,
Right, those are the- that's exactly where it has to draw.
right? Domain, x is an element of the real numbers, intercepts, both 0, 0. Odd, even, it is even. It's increasing from 0 to infinity, it's decreasing from negative infinity to 0, and behavior as x goes to infinity. I'll let you finish this. Yeah, I'll just write it. These are both infinity, right? But on a Tuesday. Let's get to the good stuff. Square root of x. Do you know what this function looks like? Let's plug in some numbers. What's the first one we should plug in? Even before 1, let's plug in. Should we plug in a number less than 0? No, that would take us to imaginary land, and when we graph, we never graph imaginary numbers unless it's on a complex plane, which is out of the scope of this class. But when we plug in a zero, out comes. Wait, what is the square root of 0? It's 0. How about the square root of 1? Should I plug in a 2? No, let's plug in pretty numbers. Well, pretty numbers for this function. The next number we're going to plug in is 4. We know the square root of 4 is 2, and we also know that the square root of 9 is 3. Is that it? I think that's all that fit on the grid here. So we connect this. Do you recognize the shape? Does it make sense that this is half of a parabola? Like the 1, 1, 4, 2, 9, 3. Then we see those same numbers just flipped for the parabola. So it's just half a parabola that's going open sideways, but it's half a parabola. It should look up there. So this is finally an interesting one, a little bit more interesting. Domain starts at 0 and goes to infinity. So you can write it in interval notation, or you could also say that x is greater than or equal to 0 if you want to do something like that. Intercepts. Does it have intercepts? Yeah, both are 0, 0. Is this odd? Even? Neither one. It's increasing? Decreasing? Yeah. Increasing from 0 to infinity. End behavior. As x goes to infinity, f of x. Does it go all the way up to infinity? Yes, it goes very slowly, doesn't it, compared to a parabola? But it still goes to infinity. Can't get up to 1,000,000. Gonna take 1,000,000,000,000 to get over there, though. Should I continue this end behavior? No, the other end makes no sense. This only has one end. Is there a question? For relative minimum and maximum? Actually, yeah, good question. Is it increasing at 0? When we did this, we left it in bracket form because that's like the bottom of like the relative minimum, but we haven't discussed that. It's pretty ambiguous, isn't it? So I wouldn't mark off if you left it as.
But on the other parabola, should there be bracket?
On parabola, that's a relative minimum, so it definitely can't include that. But this is not relative. Absolute minimum. So is it increasing at 0? I could see arguments for and against. Calculus should say yes. But this is not a calculus class yet. Maybe I'll see you on calculus in a couple of years. If I'm lucky and you are not. Moving on, the cube function. X cubed. Okay, what number should we plug in? How about 0? Okay, 1. What's 1 cubed? 1. How about 2 cubed? How about 3 cubed? It's not going to fit on the grid, of course, but you can imagine where that one is. When you plug in a -1, out comes a -1, -2, out comes a -8. I think that's all that fits on here. So it kind of looks like a parabola on the right, doesn't it? Like going up much faster. And on the left, it kind of looks like a downward spacing parabola, but going down equally as fast as it is going up on the right. Domain. X is an element of the real numbers. Let me write that so it's an actual letter. Intercepts. Oh my gosh. Does it get more tedious than this? Is it odd? Even? It's odd. Is it increasing? Decreasing? It's just increasing? Yeah, it's increasing. From negative infinity. I'll accept negative infinity to infinity. Although calculus would say negative infinity to 0 and then 0 to infinity. Like it kind of levels off briefly and then goes back up. But for our purposes, it's just going up negative infinity to infinity. End behavior. As x goes to infinity, f of x goes to infinity. How many more of these? Oh, this is the last one. Woo. Okay. Go ahead and build the cube root function. Please. It's got to be a partner. What are the good points to plug in here? Okay, I need some help making some points here. Do you have enough time? Oh no, I don't. I just make that up. I should though. I'm not the thing. Get chaotic though with the wrong question. Explain something. Sasha, what points did you plug into, please?
0 and 0.
Okay.
And then,
Okay.
and then 8.
Do we agree with these 3 points? Do you have any other points? Good question. She has posed the question. Give me a thumbs up or down. Does it work with negative numbers? Give me a thumbs up so you may proceed with negative numbers.
So, 1 out, and then 1.
Okay.
And then
We agree? Cool. Yeah, so what we have here, does this shape look familiar? A little bit. Have you seen this shape before? Yeah, we just made it, didn't we? It's just horizontally oriented rather than vertical. The shape is called a cubic. Thank you, Sasha. That was great. Okay, so there we go. That's your library. These you have to know. How well do you have to know these? Very well. Like what? Back of your hand. You have to know like the. Does anyone really know the back of your hand? I wonder. Could you draw the back of your hand without looking at the back of your hand? That's a whole other thing. That's an artistic skill. If you saw a picture of the back of 10 people's hands, would you recognize yours? Probably. Anyway, you got to know it like this. That quick. Bam. So no more of these T-charts, right? If it's y equals some number, you know, it's a horizontal line. If it's y equals x, you know, it is a diagonal line exactly with the slope of 1. If it's y equals x, absolute value of x, you know, you have to know the shape is a V, always like this, with slope 1 and -1. Does that make sense? It has a slope of -1 on half of it. Okay, and you have to do all of these. How fast do you have to know them? Like that. No T-charts. No, just plug in a 1, you get a blah, blah, blah. Right, that's just building blocks. So we have to know these code. Okay, so what I'm gonna do is, I think this is a good time to just maybe look at them, breathe it in. I'll resume the instruction at 8:41. Anyone travel to see family for Thanksgiving? Lily, where'd you go? Oh, nice. What part? Okay. Was it freezing?
No, we really don't actually. It's like-
Okay. So really warm for East Coast standard. Cool. Anyone else go anywhere? Go see some family? Anyone have family from out of town? Mia, where did you have family coming from? Yeah. From Boston. Okay, so maybe they crossed the family on the way over. Okay. Nice. Sienna, where did your family coming from? Oh, where is he? Nice. I barely know him, but I'd recognize. Open cup.
Big water.
I was water. Thank you. Hey, it's 8:41. I don't need to torture you with my awkward conversation. All right, let's go. I'll torture you with education. I mean, teach you with education. So just like we had some functions before, it's a library. This is not a library function here. This is just a function. We're going to be doing what's called a transformation to it. Notice we start with y equals f of x. This is y equals f of x. Ta-da. We're going to draw a transformation of this function, y equals f of x plus 2. So notice what's happening. That plus 2 is being added to the y values, aren't they? My f of x is a y value, f of x plus 2, 2 being added to the y values. So what I'm going to do, I'm going to redraw the original function on here in the dashed format. I'd like you to do that too. Okay, so you have this already? So right now we have how many points? Oh, let me make sure I'm being recorded here. Just a second, please.
Check 1, 2. 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 Okay, I'm just gonna hope that it's working. Because yes,
See what's going on. Okay, so all the points they see here are just gonna go, the y values are gonna increase by 2, which means they're all gonna go up 2 units. So I'm gonna take each one of those and just raise them up. Using transformations should make your graphing a very pleasant experience. Right, there was no T-charts there, and just took a basic graph, moved all the points that I knew and moved them all up. That's it. Okay, so in this case, use a graph of f of x equals absolute value of x to obtain the graph of g of x equals absolute value of x minus 4. Do you know what the graph of f of x equals absolute value of x looks like? Can you show me what it looks like? How quickly did you know that? How quickly did you access that information? Like that, hopefully. It's a pretty straightforward one. So I'm going to make a dashed version of this. on both sides. Now notice the y values here are being taken down 4, right? Absolute value of x is that's our y value, so it's everything's gonna go down 4. I'm gonna take all the points that I know here. Bring it down 4. No T charts necessary. The summary of vertical shifts, if y equals f of x, then y equals f of x plus b results in a vertical shift of b units. Should I include negative also? Should I see plus or minus b? No, because b could be negative. That would just complicate things. So, like here, b has to be negative plus negative down. Oh, shift, yeah, vertical shift. This is AKA. AKA stands for, also known as, it's a special type of transformation. This is a translation, or sometimes called a slide, which I think should make perfect sense. Translation, I don't know why it's called that, but slide down, slide up, etc. Okay. In this case, notice we start with the same function, but that -2, that 2, is no longer affecting the f of x, affecting the x, which means it's not going to go up and down. It's going to go left, right. But which direction is it going to go? Okay, so if it goes, let's dot in the original function. Oh, I have to dot it correctly. Okay, so I'm going to, don't write anything yet. I'm going to say that this goes here. To the left. Let me check this. If this is right, I'm putting -6. Okay, -6 minus 2. It's -8. What is that to be -8? What's happening is we've gone the wrong direction. I know it's strange. Let's see what happens if we go the other direction. And remember, what I'm graphing here is f of x minus 2. Let's say I go here. If I plug in a -2 here, I get f of -4. F of -4 is -1. When it's here, when it's tucked inside the function, it's counterintuitive. It's always going to take you the opposite direction of what you imagine. So instead of 2 to the left, it does take you 2 to the right. It's kind of like, how do you get back to the original function? Everything about it, it's counterintuitive. All the points that we started with are going to go 2 to the right. I know, it's weird. It's crazy. Let me go back to black points. anytime you're doing a transformation, I am gonna wanna see the original and the new. The original has to be in dash. Sometimes, if you wanna bring like a colored pencil or something, because sometimes I have more than one transformation, you could do that. Use a graph of f of x equals square root of x. Do you know what the square root of x looks like? Please show me in the whiteboard right in front of you with your finger as the marker. So at the origin, it goes. How fast did you know that? Like that. I'm just gonna put in a few points. I think only 3 points actually fit there. Remember, these are gonna be dashed, like your hopes and dreams. I mean, like my hopes and dreams. X plus 3. Notice that plus 3, it's inside the function, isn't it? We're dealing with the horizontal translation. Moving 3 to the counterintuitive is 3 to the left. I want to make sure that this works. I want to make sure I did it the right way. How could I check to make sure I did it the right way? Yeah, I'm gonna plug in f of. That's why we made it in 3. Don't think that's the place to set it. Maybe 3, let's plug it in. Notice what we get. It's magic, right? Let's do one more, just in case it's the freak accident. F of. Negative 2, I put it in that one, but have that negative 2 gives us 1. It's perfect. You put it the other way, it wouldn't have made any sense. It's inside that case, it's counterintuitive. So the summary, if y equals f of x, then y equals f of x minus, I'm going to do h here. Results in a horizontal shift of h units. Notice that h does not include the doesn't include negative. And that's just the definition here. And that's what makes it counterintuitive. So like this, and mathematically we're thinking g of x equals square root of x minus. What, how can I write this? It's supposed to be the same as x minus negative. But it resulted in a horizontal shift of negative 3 units. That's just by definition. I don't think about it this way. I think it's counterintuitive to what you actually see. So here, notice or note change is inside the function. Inside the function. And let's just go back up after you finish writing this down. Let's go up to these. So that this change is. It's outside the function, isn't it? But let's look at the example. Hope that makes sense. Isn't that outside the function? I'm always gonna be referring to inside the function, outside the function. I just want to visually understand what I'm talking about. So I need to just addend this, make an addendum. Note, change is outside the function. Any questions? Okay, oh, look at this. We have some examples. Parent function. Parent function means which library function you have to reference in order to get this function. Do you see what the parent function would be here? Y equals x squared. Parabola. Please discuss with your neighbor. What are the transformations that can happen to your parabola? I will be calling on someone for this one. Well, actually, I'm gonna call on everybody. Let's go from left to right. Please show me what this is. You have a problem, right? Show me to the right, and then show me the up. Are we good with that? So we're gonna start by a dashed parabola. And just like you said, each one of those points, I'm gonna move a 2 to the left and 3 up. Oh wait, 2 to the left. I'm sorry, you said 2 to the right, didn't you? I need to break out the ceiling here and make it happen. Any questions? I just want to check to make sure this is right. And do that by typing in. What number should I plug in? Let's see if I got this right. If I got this right, when I plug in a 2, the output should be 2. Does that work? Not even. I want to check just one more. Just one more. Which one should I plug in? If I plug in 3, then the output should be 4. Does that work? It's perfect. No T-chart necessary. We take this rigid form that we have. This is really good. Very, very right. Yes, oh, I recommend you don't have to check it. I'm not really sure about saying it right. It's just educational part. Just to make sure. 7, 8, and 9. Which reminds me of a great math joke. Right? You know that one, don't you? Yeah, I'm not gonna tell it. 7, 8, and 9. But you know another great math joke. What do the zeros say to the 8? Have you heard this one? What do the zeros say to the 8? Oh, this one's good. No? Nice belt. Huh? Huh? Good. What does the 0 say to the 8? Nice belt. Oh, it's so good. I'm sorry, I told you to do the math check. I'll be asking three people. Three people to help with these. Dash. Fine. Oh, I didn't write the transformations. Two to the right, three up. Right, so
Have a little. Visual, visual, visual.
ooh, good question.
That's what you need. Keep around.
Take with the neighbors, see how number 7 is going. Remember, no two charts. Now in your brain. Now they're all. I'm gonna call 3 people to come up with a graph. James, I'm gonna have you do number 7, please. When he's done, Sienna 8 and Lily 9. So all I want is the dashed original and then the final graph. I don't need all the other information. Yeah. Yeah, you're ready already, huh? Yeah. Kristen, I called you in November. I'm sorry. Took so long. Yeah. Because I was having application. Oh, what's going on there? That's not right. Sorry. There you go. Oh, it Shoot. Yeah, yeah, but I get it there. I'm sorry. Yeah. I need to move it left, right, don't I?
Seven, the bottom should be a -1.
Oh no, why did it do this? Sorry, just a second.
James is perfect.
What's going on here? I have to get James right, because his is, okay. Oh, yeah, yeah. Wait, did I get it? Right about there? Okay. Like a new or something? Oh, I see. Maybe this, maybe this. Maybe this. Is that getting there? Wait. I want to be perfect. Is this right about there? I think it's pretty. Oh, I muted it. Sorry. Ah. You want to start on your assignment? A little bit of time. Way back time. Good. Anyone look at the correct direction? One right. Um, I do want to say applicant. I didn't mention that before. But now you're gonna show the applicant. With a dash line. Exactly. Yeah. Good. The kind of guide. Here's that. And although these are both called branches, I don't know if there's actually a shape for the plan function. I think the shape is just the shape of one over X. Parabolas need to know lines, V's, other than that, shape of a cubic or a 1/x function. So you have a few minutes to take a look at that first assignment. Great job, that was a ton of stuff. Something for the people at home.
And I'm really not, man. You know, where you put 2 points that I know. And those are always like there about there. I have all that. Those are the two.